Our next food-related chapter is food preservation, safety, and I also have some foodborne diseases in this. The foodborne diseases aren't specifically in chapter 13, but it's most of them are in the book somewhere. Okay. One of the most traditional ways to preserve and keep food from spoiling is with spices. And there's probably a lot of debate whether people use spices just for the flavor or whether they use them mostly as preservatives. Um, when you look at these different foods, milk, meat, fruits and vegetables, seafood, and grains, uh, you see that a number of things are lost. Okay, with fruits and vegetables being up to 50%. The more you can store something, the longer you're going to be able to have it to be able to consume. Um, in the milk category, uh, the reason that we can consume so much of it is because a lot of milk is turned into cheese, as we talked about before. Okay, so we can categorize our foods into being highly perishable, semi-perishable, and non-perishable. And I think some of these things are kind of obvious. Things like milk and meat are going to be things that are going to go bad quite easily. Things that are semi-perishable will last a bit longer, but not forever. And some of the non-perishable foods really will last for pretty close to ever. Now, when we're looking at those things, there are several intrinsic factors that can help you be preserved or to keep from perishing. One of the things that things are going to move or spoil quicker if they're very moist. Okay, so water is a key. When you dry things, you get almost nothing that's going to spoil. Now the pHs, if the food is going to spoil quickly, these things are all very neutral pHs. Okay, when you have things that are acidic, then that's going to prevent those from spoiling. You can also have the physical nature of the product, and that is that if you cut meats or grind meats, those will be quite easy to spoil, whereas a whole piece of meat is going to be much harder for any of the spoilage to occur. And then if you don't refrigerate things, so that we're looking at the temperature here, if you don't refrigerate things, foods will go bad quite easily, but with refrigeration, you're going to be able to preserve those foods a lot longer. Okay. One of the keys to when we were talking about microbial growth was that most times you need air, and so these ground meats have all been vacuum sealed, and by taking the air out of there, you're not going to get any of the aerobic bacteria to be able to grow. Same thing here. When you process the meats, you can chemically modify them so that they won't spoil. Things like bacon are very highly salted, and the high salt prevents the bacteria from being able to take over. Okay. Radiation is used to preserve a number of meats um, pork, poultry, and other meats. And around 1986 to 1990 was when this process started. And we will most use gamma rays. Gamma rays are very penetrating, and they're safer for the workers as opposed to, say, X-rays. Okay, and it's not a perfect system. It's not a sterilization system. It's just going to reduce the number of bacteria that are there, including the bacterial pathogens. And the cells are just not going to be able to survive because of the damage to the DNA, and so the bacterial cells just won't survive. Radiation is kind of interesting. We definitely have to label it in this country. One of the things that I think people are really, really afraid of and are misled about, and that is that the radiation doesn't cause any quality in taste, or it doesn't change the nutritional quality. Okay, there'll be certain people who will say, "Oh, well, I don't want something that's irradiated." One of the things to think about with radiation, there's nothing left. Okay, it's not like there's some nasty chemical on the surface of that food. It's just not. The radiation has killed the bacteria that it's going to, and just isn't there anymore. And one of the things that's important is that you must handle everything appropriately after you do the irradiation. And so since it doesn't sterilize and is generally a pretty good growth media for bacteria, as long as you wash your hands well and handle everything appropriately, then you won't get contamination. Okay. There are here's a list of other foods that have been approved for radiation. Wheat flours and potatoes as far back as 1964. And some things like spices are again 1983. So here just kind of a long list of all the foods that are approved to be able to do radiation with. Okay, there are a number of specific terms that we can use when we're talking about foodborne diseases. The first, food poisoning, and in food poisoning, the source of the pathogen is the food. Okay, this is generally overused. The term food poisoning is very broad, but here our pathogen is in the food. Now, foodborne infection, the food was just a vector, and the pathogen itself only really starts to grow once the pathogen colonizes the GI tract and will make a toxin or becomes invasive. In food intoxication, here we have a toxin that is in the food, so the bacteria deposited in the food, but the bacteria aren't really there anymore. Okay, so food intoxication, it isn't key that there is any bacteria still there. Okay. And here are a number of different kinds of foods and organisms that can cause foodborne disease. I'm going to go over most of these specifically, and one of the really interesting ones, I think, uh, is the Francelia uh, is only from rabbit meat. Um, okay. So, Bacillus cereus is one of the types of food poisoning that we can have two forms. We can either have the endemic form or the diarrheal form. Endemic is just vomiting, and a diarrheal form, obviously, you have a lot of diarrhea. Um, in terms of incubation, uh, the vomiting will start in about 2 hours, but it's definitely less than 6 hours. And with the diarrheal form, it's usually about 9 hours and definitely more than 6 hours. Uh, the vomiting can uh, be done, um, in about 9 hours, where the diarrheal form will be over a day. So this is one of the um, things one has to think about. And not only did you cook the pathogen out, but what happens if your food gets contaminated? Then what's going to happen on how you preserve it? So if you're preserving with temperature, okay, if you have a fairly small dish of something, okay, in this case rice, um, the initial temperature will go down fairly quickly, so that in about an hour and a half it will reach uh, at least some safer level where it's not going to have the bacteria multiplying. If you store that in a big, deep dish, it takes a lot longer for the temperature to come down, and in this case, you have 4, 5, 6, 7, about 8 hours that those bacteria could be in a prime range that the Bacillus cereus could multiply. Now, most of the lower GI infections are one of three types of bacteria, either Vibrio species, Campylobacter jejuni, or Enterobacteria in general, Salmonella, Shigella, or Escherichia. And the Enterobacters are very hard to separate, even in a laboratory. So that's why we just sort of categorize all the lower GI Enterobacters as just those enteric bacteria. But they're one of these three species specifically. Okay, for salmonellosis, the causative agent is an enterobacteria, and the Salmonella enterica is the new name. This is a gram-negative bacteria, and one of the things that, like I was saying before about the incubation times, one of the main ways to be able to diagnose the food poisonings are how long it's taken between the time you ate and when you're getting sick. Salmonella, diarrhea and vomiting. In rare cases, you can have fever, headaches, abdominal pains. And one of the things that the salmonella does is it's actually invading the tissues of the small and large intestine. Okay. Usually how we get the salmonella is food that's contaminated with animal feces. One of the things that's very common, so like the eggs are very common to have salmonella. Now, the infectious dose, or in other words, how many salmonella have to be present so that you get the disease, can vary. Some things like hamburger, you only need 10 to 100 um, bacteria present, but some things like if it's more processed, you might be able to get 10 to the 7th before you'll actually get any sickness. Okay. Here's some salmonella on some intestinal cells. They're gram-negative rods. Okay. Another gram-negative rod would be the E. coli, and we can actually divide the E. coli's into a couple different categories. The enterotoxigenic, which we're just going to have two different kinds of toxins that are going to be produced. Enteroinvasive, here those E. coli actually get into the cells of the intestines. Enteropathogenic, it will attach to the bacteria will attach to the small intestine or large intestine, and usually there's a loss of the microvilli that are part of the intestine once you get the enteropathogenic. And enterohemorrhagenic, still we get that attachment and that invasion, but now we are releasing a lot of the Shigella-like toxin, and you can have quite a bit of bleeding. This enterohemorrhagenic, the EHEC, is the 0157H7 that you've probably heard about. Okay. Now, outbreaks of 0157H7 have occurred in a number of different foods. Some of them seem a little bit easier to think about, that the E. coli would have been an vector, so something like ground beef or water kind of makes sense that those could be carried in those foods. But things like a salami or lettuce don't seem as popular in terms of being a vector, but it definitely has happened. And one of the things that really sort of so grosses me out, the reason that things like lettuce become a vector or a vehicle are that while the people are picking the lettuce in the fields, they generally defecate in the fields. They don't have time to take a break to go use a bathroom, so they just do it right there in the field, and then that contaminates the lettuce. Okay, and here's the incidence of E. coli 0157 versus years. 1999 and 2000 were pretty big years, and these are the number of incidences per 100,000 of the population. Per 100,000 is a very standard measure of disease. Okay. Here, salmonella, a bit higher, and these are the national averages for the U.S. per 100,000 population. One way to think about that if you think about the city you're living in, multiply the number of 100,000s that are in the city where you live, and then multiply the number here, so like 17, multiplied by um, just 1 for 100,000, 2 for 200,000, will give you a number of the cases. Okay, incidence per 100,000 is giving you the prevalence, but not really just the raw number of cases. The next disease that we'll talk about are Clostridium perfringens food poisonings. And here's just a microscope picture of the Clostridium perfringens. It's a spore-forming bacteria, and if you look very closely at this picture, you'll see the spores, which are not as dark blue on these cells. The spores just can't be stained. Okay. Clostridium perfringens has an incubation time of 8 to 24 hours, and you have abdominal cramping, a lot of watery diarrhea, but there's no fever, nausea, or vomiting. And Clostridium perfringens food poisoning generally lasts less than 24 hours. Clostridium perfringens food poisoning isn't reported very often because most people might have it, and they'll because it goes away in a day, they don't really try to get any treatment for it. Now, something that we really have to try to get treatment for is foodborne botulism. And this is another Clostridium species, Clostridium botulinum. And the symptoms include dizziness and weakness a day or two after you consume that contaminated food. And one of the very first things that you might see when you're seeing that it's really botulism is that you have blurred vision. Okay, the key to botulism is that you're getting some sort of paralysis. Okay, so the reason you get your blurred vision is because the pupils become paralyzed open, and then you you can't focus your vision very well. Usually you can die of botulism by literally suffocating to death because your lungs have been paralyzed, and so you can't take any new air in. And one of the things, and I'll say it more when we're talking about toxins, but this is an amazingly dangerous toxin that's produced by Clostridium botulinum. And so people who get Botox injections, I'm a little nervous about it because it's definitely easy to over-inject the botulinum toxin, and it's a very powerful toxin, so you have to be very careful that you're going to someone who is not going to put too much Botox into you. Okay. When thinking about food, we can use the 240-140 rule. Okay, and you should pretty much always use the 240-140 rule with most foods, but anything that needs to be refrigerated, okay, if it's been kept out for more than 2 hours between 40 degrees and 140 degrees, or in other words, the prime area that bacteria are able to grow in, if it's out for more than 2 hours, just don't eat it. Okay. If you are refrigerated less than 40 degrees, or heated greater than 140 degrees, then you're okay. But this is one of the problems people have with picnics, is that they don't keep things cold or hot for long enough, or they just let it into that prime bacterial growth phase for just too long. Here's the 240-140 rule, but thinking about just the temperatures, and somewhere between 40 Fahrenheit and 140 are the places where the most bacteria are going to be able to grow.